In yesterday's class, we discussed about the basic programming structure and how a COBOL program looks like, and this compilation execution process, right? So the highlight
Yeah.
of yesterday's class was, if you have any doubt, you can ask me first.
No, not no doubt
No
till
doubt
now.
for me. Yeah.
Okay.
Yeah.
So from this first class, what kind of questions you can get in interviews? Okay. First thing is, what is an object code? What is object code or what is load module? Why a object
Okay.
code is created? Okay. This kind of questions may be asked. It's not very important, but it may be asked in interviews. So you can say that object code is the executable form version or executable format of source code. When we write a source code, it is not executable. Mainframe is not able to execute the code. So we have to convert this code into its executable format, that is called object code. Now, how do you compile? Second question. What is compilation? So what is the utility for compilation? What is the utility for link edit? So you have to say that
Okay.
utility for compilation is IGY-CRCTL. Utility for link edit is IWL. Okay. Then you
Okay.
have to
Okay.
execute the program. So these are basic uh, things about yesterday's class. And also the next question would be, what are the divisions in a COBOL program? Okay. So you have to say we have 4 divisions in a COBOL program: identification division, environment division, data division, procedure division. The next question he'll ask is, which are the mandatory divisions in COBOL program? You have to say identification and procedure division are the mandatory divisions. Then he'll say, what are the parameters under identification division? You have to say program ID, author, date, return date, compile, installation. Which one is mandatory? Program ID. Okay. Now,
Okay.
next is where the file is where is the file defined, where is the file mapping done in a COBOL program? You have to say inside environment division, input output section, file control. You have to do the file mapping. Where is the file structure defined? It is defined inside data division, file section. And where is the business logic written? It is written inside procedure division. What is stop run? What is the use of stop run? Stop run is used to stop execution of the program, because if you don't use stop run, the program will keep on running. It will not stop. So when we write stop run, it completes the execution of the program and stops the program. Okay. So these are the highlights of yesterday's class. class. Okay.
Okay.
Now here there are two more things. One is called area A. One is called area B. Now, what is area A, area B? So, as we discussed yesterday, that a COBOL program starts from eighth position. It always starts from eighth position. The first 7 positions, in the first 7 positions, we don't write anything. It is blank. Now, what is area A? The lines which start from position number 8. Position number 8 is called area A. So, in area A, which are the lines that will start? All the divisions, all the parameters under division. Okay. Then paragraphs, sections, these things will start in area A, position number 8. What is area B? Position 12. What will start in area B? All the business logics that we write inside procedure division will start at position number 12, area B. So if you don't maintain this area A, area B concept in your COBOL program, you will get error while compiling the program. You will get compilation error. So you have to start writing the program from eighth position. What will you write from eighth position? Identification division, all the 5 parameters of identification division, environment division, all the parameters under environment division, file control. Then only these select statements will you have to write from 12th position. But again, data division, all the things under data division, everything you have to write. Just 1 second, I'm getting a call, huh? Okay, sorry. So all the parameters under data division, then Inside procedure division also is written at area A, and inside procedure division, whatever you write will be written in area A except for some lines. Okay, will be written in area B, 12th position. Got it? Now, this is a COBOL program which you have written. Suppose this program is 1,000 lines long. Now, since it's a small program, anyone can understand. But if you have written a program of 1,000 lines and you leave the company after 1 year, in place of you, someone else comes, and the entire team is new, suppose, and someone looks into this program, it will be very difficult for him to understand the logic of the program. If he opens the program, it will be very difficult for him because it is 1,000 lines long. He has to read through all the lines and he has to understand the flow of the program. It will be very difficult for him. To make things easier, it is very important that we write some descriptions about the program. So, generally, you can write the descriptions anywhere, okay? You can write after this identification division also, here also. So description as in, you will write, this is a sample display program. I have simply written, this is a sample display program. But I have written it inside the program, right? This line. But this line I don't want to execute because if the mainframe tries to execute this line, it will not be able to convert it. Convert this. This is not a code. It's a statement that I have written, a description. So I have to write it inside some commented line. So at seventh position, I have to give a star. So in whichever line at seventh position you have a star, that line is called a commented line. Meaning this line is only used for description purpose or to write some things which are not part of the execution or which are not part of the code, but just for our knowledge. So sometimes you'll see they make this kind of designs, okay, just to make it separate. Then after this line also, okay. So all the other lines you see there is nothing at position 7. That means it's a valid line. But for these three lines, we have star at position number 7. So the mainframe, while compiling, will understand that these three lines are for description purpose. We don't have to convert them into its executable format. Okay? This is how the description is written. It's part of COBOL coding standard to write each and every thing about the COBOL program. Here, even though author, date written, date compile, and installation were not mandatory, but still we write in real time so that maximum information we provide in the program. And if a new person comes and he opens the program, he can see everything. Now, if your program is too big, like 1,000 lines long, whatever logic is there inside the program, in short, you can write that this program is updating this thing in this table, or this program is inserting this data in this table. This kind of things you can write in descriptions. Okay. So this is the first time change. Suppose first time you have written this program from scratch, and this is what you have written. You have delivered this program in 2022, suppose. After 2022, suppose 1 year after 2022, one new requirement came for which this same program was changed, was enhanced. Who changed? Someone else changed, or you only changed. Now since this program is already running in production environment, you have to take the fresh version of this program and you have to code whatever you have to code based on the requirement. You have to code in the program. Now all those lines you have to tag with some numbers. Okay. Okay, meaning you know Jira, right? Jira agile process.
Ah, yes.
So all your tasks come through Jira, right? There is a Jira number to every task.
Mm.
So whenever any development work is given to you, there will be a Jira task created. So that Jira task number you have to provide, you have to write before every line when you code. Suppose the your Jira number is suppose Jira 100. This is the requirement number. Give a hyphen or anything. Um, Updating new account fields. Suppose as per the new requirement, you have to update the new account fields, and these fields are coming from input file. This was part of this item, so you have to add one line also as description. And who did this? You can write like this. Your name also you have to write, and what you did in this Jira item you have to write. Now, all the lines you have written inside this program newly as part of this requirement, before every line you have to write the tag. The tag can be written here in the 7 positions. For example, if you have written this way, update something, update table, something you have written, dot, dot, dot. I'm not writing the full thing. You can write the this way. Okay? You can write it this way. Keep the 7 position
So,
empty this way. Hmm?
so first six lines we can write Jira. Like,
Yeah, yeah, yeah.
is that okay?
In the first six
Okay,
positions,
okay.
you can write the tags. Always you have to write so that anyone understands. Suppose you have written it and you have delivered to production, something goes wrong, then you can easily find out which are the lines which were newly added as part of this new change. You can just search with this inside the program and easily you can find out the new lines. Otherwise, if you don't write these tags, then it will be very difficult to find out if anything goes wrong. So these are also part of COBOL coding standards. We have to always mention. Now, after writing this, you deliver this to production. It runs after 1 year or 6 months. Again, a new requirement comes. Then what will happen? Then again, someone will do the changes. He will again add one more line as description, and whatever lines it adds or deletes or comments out, he has to write the tag number here. Always always remember that for all the valid lines, keep the 7 position empty, and all the description lines keep star in 7 position. Got it? Any doubt?
So for example, like first person changes like Jira number some 100, and another person comes and they're also making changes with Jira 200. So if a new guy comes and he will eh, update any new things, how will they get to know like which one is newly updated? Because both the Jira will be there, right?
Meaning? Because a new
Like
person,
Jira.
whatever change a new person will do, he will do as per his requirement, which will be mentioned in the Jira item.
Okay,
It
okay,
is
okay,
not. It is
okay,
not related. Jira 100, Jira 200, these are not related. It was a requirement which came, suppose, in 2023. In 2024,
okay,
one more requirement came. A new
okay.
field, suppose you have to update or insert whatever. New requirement came. Someone else was assigned with this task. He changed this program with the new code, and he has to write his description and his codes, I mean the tags, whatever changes he does in all the lines, in all the new lines. So these Jira 100 and 200 are not related. These are two different tasks. This is how when you work, you will see whenever a program is delivered, if you check the version control tool, you will see that you will see all the versions of the programs that are present in the version control tool. If you see there are 7 versions of the program, that means this program was delivered to production 7 times. When the first time it was delivered, suppose it was delivered in 2019, first time, it was a new program totally. It was written from scratch. Second time, some lines were added or some changes were done on the program. It was delivered. Third time, again, some lines were added like this. It kept on changing every time. So this happens. These are called enhancements. Okay,
Yeah. Okay, okay.
clear now?
Yeah, for me
Now,
it's
Yes.
clear.
have you downloaded this
Yeah, for
software?
me also.
Have you downloaded this software yesterday?
Yeah, like we have one mainframe ID already. Like we already purchased one ID.
Oh, okay, 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 okay. Then in that one you can log in, right?
Yeah, for me it's okay. Like for another person, like we'll share. Like you said, like one ID for both of them. So one ID either me or Vignesh will use. Other one will use.
Okay, okay,
Anyone use.
okay. I'll
So
give the
so
credentials after this class.
okay, okay, yeah, sure, sure.
So the login thing I will show you later on. So I'll directly show you know now how to create PDS files and all of that.
Mm, mm, mm.
Yes.
Yeah.
So I already have some PDS libraries. I'll go to this one. Sorry. And always, so many people, what they do is they open the PDS libraries also in edit mode. It's meaningless. Don't open any PDS library in edit mode. What is the meaning of it? There is no meaning. Always open in view mode. Okay.
Okay.
Then what I'll do is I will create a new member. So if you have any doubt with these commands, you can ask me later on. But for now, so this is a COBOL program. This is a member I have created. I'll write a COBOL program. Okay. So first I will give the columns. Now I will insert one line. So first 7 positions you can keep empty. From 8th position you can write, okay, identification division. See, it will come in red color. All these are keywords of COBOL. All these will come in red colors. Then we'll write program hyphen ID period space the name of the program COBOL PGM period. See, the name came in green color. This program ID is the keyword. It came in red color. Then
Yeah.
author, my name. Then date 2025 hyphen 01 hyphen 30. Date compiled 2025 hyphen 0 hyphen 30. Then installation. So client name I have written ABC. So all these are part of identification division. 5 parameters.
Okay.
Identification division is mandatory. All the COBOL programs will start with identification division. Program ID is also mandatory. If you don't write these 4 lines, it's fine. Then this will be a sample display program. So there is no file. So we'll not use environment division and data division. These are not required. Okay. I will directly go to procedure division. Environment division and data division are not mandatory. Whenever you use files, then only environment division is required. You use files or variables or you link to programs, then data division is required. Inside procedure division, now the main thing will come. So from 12th position I have to write display hello world. Then I have to write stop run. Now you can see there are many colors here. Red,
Mm.
green, blue, white, and yellow also is there. These are all yellows. This period. Now red colors are the keywords will always come in red color. Which are the keywords? Identification division. If you do a mistake in the spelling, it will not come in red color. By the colors, you can easily find out whether you have written it correctly or wrongly. So identification has come in green color. That means there is something wrong. So see, now it's fine. Identification division, program ID, author, date written, date compile, installation, program division, procedure division, display, stop run. These are all keywords. Will come in red color always. This program name comes in green color, but the remaining parameter values always come in white color, pale blue color. Okay. Now, if you do any mistake in the names, nothing will happen. These are just information. In place of my name, if I write someone else's name, the system will not know, right? Who has written the program. So you can write anything, but we should always provide authentic information. Now, inside procedure division, display within single quotes hello world. So this is a string. That means whatever you write within single quotes or double quotes also you can use, that will be printed as it is. If you want to display something which is written within single quotes, it will be printed as it is in the output, the spool. You know spool, right?
Yes.
In spool, it will be printed as it is. So it always comes in white color. You can write anything inside it. And stop run is to stop the program. And these full stops, now periods will come in yellow color. So these are all color differences. Now, if you want to write the description, you can write here also before procedure division. So just at 7th position, just make a line like this to make a design, nothing else. This is a sample display program Why have I given written 3 lines? There is no significance. You can ignore this line and this line you can delete also, no problem. But I have written to distinguish these 3 lines. Okay, these are commented lines. So it can so now if someone looks at it, he will be able to find out easily, right? So these 3 lines are, or I can make some more designs like this. So the COBOL program, no? What is the COBOL coding standard? The program should be disciplined, it should be easy to understand, and it should look good. When you open the program should look good in your eyes. It should not, you should not feel like when you open a program, oh, what is this? It's so messy, it looks very bad. So you make it look good, the program, okay? Now it's a sample display program. Very simple. It's the simplest program you can say. This is how you can write a program, okay? Now, this language, the mainframe system will not understand. Mainframe system does not understand this language. So, this is not executable. Now, we have to make it executable. To make it executable, we have to compile this program. To compile this program, we need a JCL. Now, in some projects, they compile the programs in Endeavor version control tools. In some projects, they have separate JCL, which we have here, where we can compile the programs. In some programs, they will have some tools that they can easily compile the programs. Got it? Now, any doubt till here?
No, no doubt, no doubts.
I'll show you the compilation JCL. You'll get confused here. So, this is a JCL. Now, can you look at it and tell me if you have understood something in the JCL or you have not understood anything in the JCL? What is going on? Hmm?
One more thing, like you said, right, in compilation JCL, we have two utilities.
Yeah, we have. Now, yeah, we have those utilities. But by looking at this JCL, what do you understand? What is this? What is going on here?
Instead of
So, see,
using IBM defined libraries, you are using your user
your
defined
library.
libraries, right?
But what is this actually? Do you know
It's
proc?
a program. Yeah.
It's not a program. See,
Mm.
whenever you have step name exec pgm equal to something, that is a program. After exec, there should be pgm. Then that will be a program. Whenever you have step name exec something directly, that's a proc. You know proc, right?
Okay,
Yes, yes.
Proc means a JCL without the job card.
Mm.
If you write
okay,
a JCL and you remove the job card, that becomes a proc. Now, what this admin has done is he has written all the compilation step inside this proc, and we are calling this proc from this JCL. It's simple. Why he has done it this way? He has made this proc generic so that anyone can use. I can use, you can use, anyone can use, and we just have to pass the program name, where the program is present, where the where the output should be generated. These things we can pass, and we can use this generic proc. If we had uh, hard coded everything inside this JCL, what would have happened is every time whenever someone compiles, he had to change everything inside the code. So to make this code very secure and very safe, we have written the compilation and linkage step within a proc, and we have added some symbolic parameters. You know symbolic parameters.
Mm.
I'll show you what is going on inside this proc. So this is the proc
okay,
library.
Yeah.
So inside this proc library, this is the member, this is the proc, okay?
Mm.
okay,
So you can ignore. These are also the values are getting resolved from here. You can ignore. So you can start from here. See IGY-CRCTL. PGM equal to IGY-CRCTL means IGY-CRCTL is the program which is getting
Okay.
executed. Now sysin is the input. What it is executing. Input is sysin. But in sysin, we have written symbolic parameters ampersand so sr sleep ampersand member. Whenever this kind of code is written, that means this is not the actual value. The actual value will be passed from somewhere else, either from this proc or from the JCL from where it is called. Got it?
Yes.
So if you go to the JCL, this is the JCLC. Source lib is this one. Where I have written the program. So from the JCL, I'm passing the actual name. This is where I have written the program. So in place of ampersand source lib, this entire name will come. And in place of this ampersand member, this value will come. This value. Here I will write my program name. That means I am using IGY-CRCTL utility and I am taking source lib and member as input. What is ampersand source lib ampersand member? This library where I have written the code and this is the name of the program. You can check. So this is my source library and this is my program. I have written the code here. I'm taking it as input inside this compilation process. Then there is something called copy library. So you can see there is something called copy lib here. You can ignore it for now. We'll get it later on during file concept, file handling. You can ignore it for now. This also is input to the compilation process. So there are two inputs. One is the source library and member. One is the copy library. Now there is some temporary file which is getting created. You know temporary file. That is why JCL is important. Temporary file is a concept in JCL where you can create the output of any step and you can create it in a system defined temporary file. You don't have to create any physical file. That temporary file gets deleted at the end of the JCL automatically. So the output of this step using IGY CRCTL, we are converting this input into its compiled format object code and we are keeping it into load set temporary file. Now in the next step, see in the next step we are using IEWB link. This is another utility to link edit. IWL is also used. IEWB link is also used. We are using this utility. We are taking the same load set which was generated in the previous step where we have the compiled version and we are creating the output into this library. So ampersand load lib ampersand member. If you go to the JCL, you will see ampersand load lib is this one and ampersand member is this one. That means you take these two as input and create the output inside this load library with the same member name. This is what is going on inside this compilation process. Did you understand?
Yes, somewhat. Yeah.
It's very easy. First step, we are using IGY-CRCTL. We are taking the program as input. We are we are compiling it. The object code we are keeping inside load set. In the second step,
Okay.
we are making it executable by taking the load set as input and we are generating the executable format in the load library. And all these members we are passing from here. That is why we have created a proc. We have created a proc. Inside the proc, we have kept everything C as symbolic parameters. Now this proc is a generic proc. We don't have to change this proc while compiling. This is created and this kept. Now whoever wants to compile any program, he can just come to this JCL, he can write his program name, his library names, that's it. It will be done. That is why
Okay. Okay.
this was created. If I had coded everything, whatever is written in the proc inside this JCL, I would have to change all these libraries and I would have to return all these correct libraries. So anyone who comes to compile his programs, he would have had to change everything. That is why we have kept everything in this proc so that it is generic. Now to compile this process, I have to submit this job. If I submit, maxis is 0. Now there is a thing. There are how many types of maxis we get? What is maxis? Maximum condition code. So when you submit any JCL, we get the return code to understand whether the job was successfully executed or not. If maxis is 0, it means successful. If it is 4, successful with warnings. Greater than 4, error. Correct?
Yes.
Now, maxis is 0 means it is perfect. There is no warning also. Warning you can ignore, but there is no warning also.
Okay.
You have written the code perfectly, and also you have maintained the COBOL coding standard properly. That means you have given proper spaces everywhere. You have maintained the alignment. Everything is perfect. 4 means most of the times you will get 4 in compiling the COBOL programs, because 4 means logically the code is correct, not logically, syntactically the code is correct, but you have not followed the COBOL coding standard properly. That is why you are getting 4. So warnings will come, but we cannot handle that. If the program is too big, it's very difficult to, I mean, uh, rectify all those warnings also. We can ignore. So most of the times we'll get 4. If we get more than 4, that means if we get 8, that means error. If we get 12, severe error. When we get 8, when we don't write in full stops or periods at particular positions before paragraphs, you will get to know about this. Severe means you are using any variable in the program but you forgot to define that, or you are calling any paragraph but you forgot to define that. You will get severe. Otherwise, 0 and 4 are perfect. So in our case, it was 0. So you can go to spool. How will you go? Start s semicolon st. You can check. So it was 0. Compilations output you don't have to check only. 4 means 0 means it is correct. Now we have to execute it. So in the same library I have kept. So files are not there. I will delete these 2 lines. So this is a normal JSL which you always see in your project. Okay, you see there's a job card. All the parameters are not written. It's a test environment. Here you write your program name. COBOL PGM is my program name. Now where is this program present? This program it's a COBOL program. It can be present in many libraries, right? In you can have hundreds of libraries in your project, and in many libraries you can have program with the same name. Now, how will the system know from which one it has to pick? Here you have to write the exact name. Now, here you cannot write the source library name. You have to write the load library name where the object code is present. So, inside this load library, after compilation, you can see this member is generated. And if you open it, this is how the code looks like. So, this is equivalent to the code that you wrote. This code you wrote, but this is not executable. You made it executable by compiling it, and after compilation, this is what you got. This is what the mainframe system will understand, and it has to execute this one. Got it?
Yeah. Yes. Yeah.
Now we have to execute this one because this is executable. The source library we cannot execute. So at the time of execution, we have to write the program name here and also the library name from where it has to be picked. Then sysprint dd sysout, sysout dd sysout. That's it. So if I submit it, maxis is 0. It has been submitted correctly. If you go to spool now, then you will see that. Oops, wait. Not this one. Okay, see, whenever you have a display in your program, you will have sysout tab generated in spool always. Where does it come from? It comes from the sysout dd sysout that we write in the JCL. So these dd sysout statements we write so that we get as many tabs as possible in the output. That is why you will see always will have 7, 8, or 10 DD sysout statements while executing COBOL program, because we might get any kind of error inside COBOL program. So to find out the error, we use as many DD sysout statements as possible, so that the tabs are created in spool to find out the errors. Whenever you have a display, we'll get this sysout in the spool. If you go inside, you will see the output. The output is hello world.